This is page 418, the exponential function review. And so on this first problem, you're going to add together the exponents. So 4 minus 1 plus 2 would give you x to the fifth. You're going to distribute the negative 1. So you'd have 4 to the negative first over 5 to the negative first. When you have a negative exponent, you're going to actually switch, put the 5 on top to make it a positive first, and put the 4 on the bottom to make it a positive first. So your answer is positive 5/4. So I would pause the video, try the problem, and then see if you get the problem right. So on example 3, I'm going to cross out this x to the 0 power because that's equal to 1, and I'm going to distribute that negative 3 to everything else. And I multiply when I distribute. So I would have y to the negative 9th, z to the negative 12th, x to the negative 21st, y to the negative 24th, and z to the negative 6th. Everything is negative, which means everything is in the wrong place. So I'm going to draw another fraction bar, and I'm going to switch the places of everything. So y to the negative 9th becomes y to the 9th in the denominator, z to the 12th in the denominator, x to the 21st in the numerator, y to the 24th in the numerator, z to the 6th in the numerator. I don't see any other x's. I'm going to draw another fraction bar. So I have x to the 21st. I have 24 y's on the top, and I have 9 y's on the bottom. So I'm allowed to cancel out 9 of those y's. So I will end up with whatever 24 minus 9 is, and that would be 15. So I have y to the 15th in the numerator. Then I have 6 z's here with 12 z's here. So 6 of them will cancel, and I'll get z to the 6th down in the denominator. Number 4 is pretty easy. Anything to the 0 power is equal to 1. So my entire answer is equal to 1. Number 5, you're going to add up the powers. So you'd have a to the 11th. And on number 6, you have the option to either distribute the 2 first. I like to simplify inside the parentheses first. So I have 8 plus 1 is 9. 9 minus 3 is a to the 6th, and then I'm squaring that. So when I distribute, I'll end up with a to the 12th as my final answer. All right, so on 7, 8, and 9, you're setting up the equation a times b to the x. A is always your y-intercept, b is always your common ratio. So your y-intercept for this problem is 2. So y equals 2 times, how do I get to my next value, and how do I get to my next value after that? I'm going from 2 down to a height of 1, down to a height of a half. So I'm multiplying by a half each time. So my equation is 2 times 1/2 to the x. We're going to see if we can do that with these words down here. Here's your y-intercept. So y equals 3 times, how do I go from 3 to my next y value of 6? I multiply 3 times 2 to get to 6. So it would be 3 times 2 to the x. Number 9 is a little bit trickier. I can see that I'm going from 12 to 6. How do I go from 12 to 6? I multiply by a half. I have to go backwards to figure out what my y-intercept was. So whatever my y-intercept was, when I multiplied it by a half, I got to 12. So my y-intercept has to be 24, so that when I multiply it by a half, I get to 12. So y equals 24 times 1/2 to the x power. Shoot, I guess I already did part of this review. Hold on, let me find a blank copy here. Okay, so on number 10, you are looking for a common base. So I'm going to skip number 10 just for a minute because number 11 and 12, they already have a common base. These both have a base of 3. These both have a base of m. So I'm allowed to take this x plus 1 exponent and set it equal to this 2x minus 1 exponent, just like over here. 2x plus 2 is equal to 4x minus 12. So take a minute and solve each of those for x, and pause the video while you do that and see if you get the right answer. So I would subtract x to the other side and then add 1. So my answer should have been x equals 2. And then I like to put my x's and make them positive. So I would have 2 equals 2x minus 12, add 12, so 24 equals 2x. So let's see, x would have to be 12 at the end, right? 24 divided by 2. All right, I can't do that on number 10 because the bases have to be the same. I'm going to make this 4 into the number 2 squared. That way I don't have to change the value of the 4. 2 squared is the same as 4. But now I have the exponents, x plus 3, I can set equal to this exponent, which is 2x. And I can multiply 2 times x because I'm distributing exponents. So I have x plus 3 equals 2x. I'm going to subtract x, and I get my answer that x would have to be 3. Okay, so here are a few more problems to try. In 13 and 14, pause the video and see if you can make a common base. And now I'm going to put the answer up. So this one becomes 5 squared to the x power. And this becomes 5 cubed to the x minus 2 power. Now you have to use the distributive property to get your new exponents. 2x on this side. And then I have to distribute the 3 to both terms, so 3x minus 6. So let's see, subtract the 3x to the other side and divide by -1 on both sides. X should be 6. Number 14, I need to change my 64 into 4 cubed. So now I've got 4 to the 2x minus 5 equals 4 cubed raised to the 3x power. I'm going to distribute here. 2x minus 5 equals 9x. Pause the video and see if you can solve for x by yourself. So I'm going to subtract the 2x and I'm going to divide by 7. So I have -5/7 as my final answer. Number 15 is a little bit different. Remember, anything to what power will always give you 1. It's anything to the 0 power. So what will make this exponent of 2x equal 0? It has to be when x itself is 0. So the answer would be 0. Okay. Here is an application problem, and it's saying the population of Emerson land has increased at a rate of 5% per year for the last 20 years. The current population is 10,123. Write an equation to represent this situation. We want to use a times b to the x, where our starting population is a, and b is what we're multiplying by. If we have a 5% increase, we want to use 1.05 because that gives us back our original population with 5% increase. And we're going to put x up here for the number of years. So now you use that equation, see if you can figure out what the population will be in 3 years, when will it reach 20,000 people, and what was the population, let's see, assume you're doing this in 2018, so this would be back 15 years. What would be the population? You can just plug in x as -15. Just like up here, you're going to plug in that x is 3. So take a minute and see if you can get those answers correct on your calculator. So I like to put mine into the y equals menu. You can calculate it however you like. I'm going to tell you the answers. So after 3 years, I should have 11,719. All I did was plug in the number 3. And if I go backwards 15 years, I'd have 4869. I can't really have 0.3 of a people, but 4869. And let's see, when does it reach 20,000? So all I did was I plugged this into my y equals menu and I went to the table. And now I'm just looking, when does my population reach 20,000 people? So it looks like by year 14. By year 14. And if I wanted to, I could take 2018 and add 14 years. All right, graphing, another strategy that you need to be able to do. Okay, graph the following exponential functions. So create a table of values. I always recommend starting with -1, 0, and 1. And these are all 3 to the x. So if I plug in -1, I get 1/3 because I get the reciprocal. If I plug in 0, I get 1. And if I plug in 1, I get 3. Okay, so I'm going to plot the points -1, 1/3, 0, 1, and 1, 3. So that's my exponential growth. It has an asymptote at y equals 0, so it never goes below 0. My domain is all real numbers, and my range is y is greater than 0. Oops, here's the line for the asymptote up here. All right, how does that change when I put a negative in front of it? It's the same function, and I put a -2. So this is a flip over the x-axis, and this is a shift right 2. So I like to just plot the points again. Like these were my original points, right, from over here. If I shift those points right 2, now I'm over here, and now I have to flip them upside down. So if I'm up 3, I'm going to be down 3 below the axis. And if I'm up 1, I'm going to be down 1, and then at 1/3. So that's what it would look like when I get flipped upside down. So my asymptote is still right here in the middle at y equals 0. My domain is still all real numbers, but now my range is that y is less than 0. All right. How are 2 to the x and 1/2 to the x the same, and how are they different? Let's just draw a quick sketch. Here's 2 to the x. Here's 1/2 to the x. So both functions have a domain of all real numbers, a range of y is greater than 0, an asymptote equation at y equals 0, an intercept of, I should write it as 0, 1, and they're continuous because I can connect all the points on these graphs. So the only difference is that 2 to the x is a growth function and 1/2 to the x is a decay function. That's the difference. Or I should say increasing for growth and decreasing for decay. Okay, so then we had some compound interest, or this is application problems. So I invest 6,000. This is again y equals a times b to the x. So my starting value is $6,000. I get a 5% interest. So I'm going to multiply by 1.05, and I'm leaving it in for 12 years. So x is 12. So that's how you would set it up. So 6,000 times 1.05 to the 12th. 10,775 and 14 cents. Okay, this time, same thing, y equals a times b to the x. The original value of the car is $15,000, but this time it's depreciating. So 2% depreciating, I don't want to write 1.02. I want to be less than 100%. I want to be at 98%. So I'm going to use 0.98 to the x power. And then you're going to plug in 8 years for x. So 15,000 times 0.98 raised to the 8th power. So you'd have $12,761.45. So these types of questions I'm not going to go over because those were more related to logs. But these type of questions, there are a couple questions like this. So if you are looking to evaluate a log, you are looking for the power that will give you the inside amount. So my base is 2. I want to know what power do I have to raise that to get to 64. You might not know this one in your head, but if you count up on your fingers, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. X has to be 6 to make this true. So this is asking you 3 to what power gives you 1 over 27. So I think you know that 3 cubed is 27. How do I flip it upside down? X would have to be -3 to flip it upside down. In part C, there's a little hidden base right here. It's a base of 10. So this is asking you 10 to what power is 1 over 1,000. So I think you know that 10 to the third is 1,000. So x would have to be -3 because it's getting flipped upside down just like number 25b. Number D is a little bit harder. They're asking you 8 to what power would give you 4. So why don't you try to solve this one like you did at the beginning where you make them both have the same base. They're both going to need the same base of 2. So I'll put the answer 2 cubed to the x equals 2 squared. So 3x is equal to 2. And I divide by 3. X is the fractional exponent of 2/3. Two other concepts that you need are being able to find the inverse. That is when you switch x and y in the equation. So I literally switch x and y, and now I have to get y by itself. So my first step, subtract 3. I'm just going to continue down here. So x minus 3 is equal to 4y. And my next step is to divide by 4. You might see the answer, if it's multiple choice, written like this, because x minus 3 divided by 4 might be unsimplified. Or you might see it as 1/4 x minus 3/4, because you're allowed to divide each term by 4. And then something else that you need to know how to do is write this in scientific notation. So you pick a number between 1 and 10, so like 9.8, and then 9.8 needs to get bigger by 6 decimal places, so 10 to the 6th. If this was going in the other direction, like if it was 0.003, you would write it as 3 times 10 to the -3rd, because you're moving the decimal in the negative direction. Hope that was helpful.